Okay, next up we're going to be taking a look at an exponential function, something we haven't really looked at much in this class. With base equal to 2, f of x has been vertically shrunk and is given by the following. So again, it's nice that the question tells us it's been shrunk from its parent graph, but we ultimately want to figure out what that shrink was. So here is our transformed function. In order to understand how it's been shrunk from the parent, we have to graph it. So here's the question stated explicitly. What is the vertical shrink of f of x? We can even put this in here from its parent graph. We normally call it p of x. So step 1 then, that leads us to step 1, which is to graph the parent function on top of the transformed function. Again, you need to understand how to graph the parent function for 2 to the x. Just plug in -2, -1, 0, 1, 2. And plot those corresponding y values, and we know it's going to have an asymptote at y equals 0. It's going to have an exponential curve. Starts out gradual and shoots up. Let's see, let's go to our little thing here. And it's in terms of pi. One second. Alright, here we go. So here's our parent function. But just remember, you need to be able to do that by hand. Here's our transform function. We can see it shrunk, right, because the y values are smaller. So how much did it shrink? And here's what you're going to do for vertical shrink. You're going to locate an identifiable point on the parent function. Now this also works for stretching as well. It's the same exact steps. And also, if you're doing steps for horizontal shrink and stretch, it's the same steps. In the last video we did horizontal stretch, it'd be the same steps for shrink. Okay, so locate an identifiable point on the parent function. So let's just pick a point that crosses the grid. So I'm going to pick 2, 4. Step 3, locate the nearest point on the transform graph with the same x value. Remember, when there's a vertical stretch or shrink, you keep the same x values, the y values change. In this case, since it shrinks, the y values get smaller. So we're going to go down to the nearest point on the transform graph that has the same x value, obviously a different y value. So that's going to be 2, 2. Okay. Now what? Last step. Divide y2 by y1. This gives you the vertical stretch, shrink, flip. Okay, so just take your y2 value and divide by y1. Now again, it's opposite. If you're finding b for like horizontal stretch, shrink, flip, you do x1 over x2 when it's horizontal. But when it's vertical, you do y2 over y1. So just remember that. This will give you the vertical stretch, shrink, flip. So my y2 value is 2. My y1 value is 4. So it's going to be 2 over 4. And this confirms that it did shrink because my a value would be 1/2. So that indicates that my f of x equation, my transformed equation, is 1/2 2 to the x. In other words, all the y values from 2 to the x have been shrunk in half. We can see that with these set of points, the y value up here is close to 9, even though it's not, right? It's actually 8. Well, let's see. 2 to the x. Yeah, let's move that down. 2 cubed is 8. And if we half that at the same value as our transformed function, we know now it's 1/2 2 to the x. But if we half that y value, we indeed get 4. Which makes sense because 2 cubed is 8, half of 8 is 4. That's going to be it for identifying vertical shrink or stretch given the graph of the transform function. If you have any other questions about this, let me know.